Okay, let's keep going. This is part C, Gauss 2027, Gauss 7 2025. Three circles have radii 1, 5, and x. If the mean is 30 pi, and what is the x? Oh, so it's just a translation and equation. Okay, translation, equation, and then that's it. So I think this space should be okay. So three circles. This is a 1, 5, and x. I mean, in terms of the radius. Okay, so the area would be pi, 25 pi, and x squared pi, and the average is a 30 pi. So the total would be 90 pi. So I would say pi plus 25 pi plus x squared pi is 90 pi. So the translation is down. Let's do equation. So it's 26. So x squared is 64. X is positive or negative 8. However, negative doesn't make any sense here. So finally, x is 8 centimeters. Right here, the answer is D. A value of x is 8 centimeters. The problem is just done. It's just translation, solving equation, nothing special. The next one, each of the three doors is painted one color, black, white, or gold, and each color is equally likely to be chosen for a door. It's independent. I mean, doors and the doors are independent from each other. So what is the probability that at least one color is not used? At least one color is not used. So this problem, I think it's best to do it using subtraction. So the total minus and all three colors are used, because if all three colors are used, it doesn't satisfy what is asked about here. So if all three colors are used, there are a total of 3 permutation, that is 3 times 2 times 1, or you can say 3 factorial. So anyways, it is 6. So there are 6 cases where all 3 numbers are used. All other cases would satisfy, and the total would be 3 times 3, right? For each door, you've got 3 choices, so that would be 3 times 3 times 3. That is 27 total choices. So 6 out of 27 does not satisfy. So 21 out of 27 satisfies, and 21 out of 27 would be simplified to 7 out of 9. So the answer should be 7 out of 9, which is A. Yeah, that's it. Doing subtraction, you don't even need to lay your pen or pencil down on the paper, just to do it mental. Yeah. But if you have a problem with the 3 permutation, I don't know, 3 times 3 thing, then it's just some counting basics which we don't have time to get deep into here. But in general, this problem is not a hard counting problem. You just consider the opposite, and that's it. On the contrary, the next problem is, is quite to the contrary. I don't know. Let's first read this problem. Suppose ABC are the last 3 digits of a 6-digit number 111 ABC. If this number is divisible by 18, how many possibilities are there for n? If you think this is a counting problem, probably you're wrong. You can still somehow find the correct answer if you doing it the regular counting way. You know, there are different possibilities. If A plus B plus C is, for example, 6, this number could be a multiple of 18, because, first of all, this number has to be a multiple of 9. So you might think that, okay, A plus B plus C plus 3, 3 is 1 plus 1 plus 1. So it's the sum of digits. A plus B plus C plus 3, maybe 27, maybe 18, maybe 9. And then you break it down to different cases, and you consider each cases. However, this is actually not a great way of doing this problem. And if you just look at these answers, you will notice that that's quite a lot. So actually, I would say this is not actually counting it's not a counting problem. It's just a sequence problem. Because, if a number is divisible by 18, this kind of numbers come up, let's say these numbers come up once in every 18 numbers. once in every 18 consecutive numbers. So actually this is a arithmetic sequence with common difference 18. If you get the first number, the next number will be 18 after, and the next number will be 18 after, and that's it. So you just need to find out how many numbers are within this range. And the range is from 111000 to 111999. So there are a total of 1,000 numbers. And how many numbers within the 1,000 numbers are a multiple of 18, right? Every 18 numbers, you've got 1. So basically, that's the idea. So what would be the first number? Let's think. The first number should be an even number because it's a multiple of 18. And the first number should be a multiple of 9. And if it's a multiple of 9, again, the sum of digits should be a multiple of 9. So the first one, easily, it is 111006. Because it's a multiple of 9 and it's an even number. There's no one before it because 111006 minus 18 is below 111000. It's out of the range. So the first number is 111006. Let's write it down. The first number is 111006. And what's the last number? The last number is 111, maybe 99 something. And 99 doesn't matter if the number is a multiple of 9 or not, because they are the multiple of 9 themselves. So the last digit, is 6 again. So if you add them up, it's the sum of digits is a multiple of 9, and this is actually an even number. And obviously, this is the last number, let's say, a satisfying number within this range. So we start with this number and end up with this number. And how many multiples of 18 are there within this range? So it's like the bigger gap. The big gap is 990, and the small gap is 18. So big gap divided by small gap and plus 1. Okay, so that is 55 plus 1, that is 56. So there are in total 56 numbers. You don't have to do those counting stuff. It's just a number. It's just a number of terms within a range when it comes to arithmetic sequence. So you just use this big gap divided by the small gap. You need to plus 1. It's like the tree planting model. So the number of trees is always 1 more than the number of gaps. So here the answer is a 56. Do we have a 56 here? Yes, we do have a 56 here. So that is it. That is problem 23.